Welcome to yet another exciting educational video brought to you by Chrysler Tutors. Here we'll try to look at topics covered in the National Open University of Nigeria scheme syllabus, and today we'll be discussing MTH 112 Unit 2 Rules for Differentiation Part 1. So the lesson objective includes apply the constant power and sum and difference rules correctly, differentiate functions involving constant multiples, then they use product rule and quotient rule to handle products and divisions of functions. Fourthly, simplify the derivative algebraically and interpret them in real problems. And lastly, solve structured questions and exercises and short form quiz questions. So if you're to subscribe to our channel, please subscribe and sit tight for this particular video. It promises to be exciting. So we dive in. So for Unit 1 in your material, recall that the derivative of a function is given as this notation. So f prime of x, which is the derivative, that's differentiating the first time, is equals to limits as x tends towards 0 for the function as the function decreases in the x domain per unit length. So this basic differentiation from first principle will make us to now get the basic rules. So I'll give us a rule, for instance, the rule, then I'll put the formula to back up that rule, then I will also give us example. So for instance, the first one I'm going to look at is constant rule, the constant rule. This is where you have constant term like 1, 2, 3, 4, 5, 6, 7, or integers minus 2, minus 3, minus 4. Understand? If you are told to find the derivative of a constant, we note it with C. For instance, any constant is equals to 0. Any constant, it could be any integer. For instance, I asked you to find the derivative of 7. 7 here is a constant. The answer is always 0. So number 2 is the constant multiple rule. Constant multiple rule. So I'll write it on the board. Constant multiple rule. So if, for instance, we are asked to get the derivative of constants times a function, you understand? The answer is that constant to come outside, then we'll now differentiate that function. The same time I put this prime here before the function, the variable in the function, it means that I have differentiated it. You see, this one now has transformed to how it is to f prime of x. F of x, f prime of x. Understand? This is f of x. F of x, please. F of x. Okay, so example. If I'm asked to differentiate 3x squared. This is a typical example where this 3 is this constant term and the x squared is the function of x. Understand? Now for this situation, I will leave 3 constant and differentiate this one that has the power. Understand? So I'll bring 3 out like this, 3 dots. I'll leave it out. Then this one now, the 2 will come down. The 2 will come down and the power, this 2 will reduce by 1 at the same time. Okay, so it is times 2x1. I will explain again. Normally, if I have x raised to power n, you understand, the differential of this is n. This power will multiply the coefficients, and at the same time, this power reduced by 1. Okay, let me not use the word power, let me use the word exponent. The exponent will multiply the coefficients. At the same time, the exponent will reduce by 1. So the differential of this is exponent times coefficient, that is n, x then n minus 1. You see? So the n is, the exponent is multiplying the coefficient of x. At the same time, the exponent is reducing by 1. So that's what happened here. 2 is multiplying the coefficient, and at the same time 2 is reduced by 1 to give me this. So of course, on the long run, 3 times 2 is 6, right? 6x. I don't need to put 1 there. So differential of this is this. Just multiply the exponents by the coefficient, at the same time reduce the exponent by 1. Okay, so that's for the constant multiple rule. Then the third one here I have here is the power rule. The power rule. The power rule. What is power rule? The power rule states that, okay, I've alluded to it here, but I will still write it down. The power rule states that if I have differential d dx of x to the power n, right? The answer is the exponent multiplies the coefficient, and the exponent reduces by 1. So n dot x n minus 1. I've explained it here already, so I'm going to put it here again. I will say, example, if I say differentiate, this symbol here means differentiate. Differentiate x to the power 5, right? So this is 5, we multiply 1, because 5 is the exponent and 1 is the coefficient. So 5 multiplied by coefficient 1, and 5 at the same time reduced by 1, that's 5 minus 1 will give me 4. So I will say 5 times 1 is 5, x, then 5 minus 1 is 4. So this is the answer for that. There is also one final one before we go to what we have next. You can just look at this, or you can copy it, pause the video, copy it. Let me just quickly add the last one. I'll remove this one, remove this one. I'm adding the last one, that's the fourth one. Okay, so the fourth one, I'll call it sum difference, sum/difference rule. Sum/difference rule. Okay, so this particular one has to do with if I'm asked to differentiate a function plus or minus another function. So the answer is differentiate first function plus differentiate second function. This problem I'm having here is that function f is differentiated and function g is differentiated. Differentiate them term by term. That's what it means, term by term. So if you have some of the difference in between them as the operator. Okay, so for example, if I'm asked to differentiate 3x squared, okay, let me don't put 3x squared, let me just say x cubed, right, plus 2x. You know that this function is actually a sum function. If there's a minus here, it's a different function. But this is a sum function. So I'm going to differentiate this term and differentiate this term. Based on what I've known so far, if I want to differentiate this term, I'll just say, okay, 3 is the exponent of this particular function. 3 times 1, that's times the coefficient, that is 3x. At the same time, 3 minus 1 will give me the power. 3 minus 1 is what? 2. So this power multiplies the coefficient, at the same time power reduced by 1. So 3 times 1 is 3. 3 minus 2 is 1. So that's why I have 3x squared. Plus, this one is, there's a power here. Power is 1, right? 1 times 2 is 2. But 1 minus 1 is 0. X to the power 0 is 1. So this one becomes 2. I take it again. I'll just segment it. This is 2x, right? There's a 1 here. So this 1 times 2 is 2 times 1, right? Then x. Then at the same time, 1 minus 1 is 0. 2 times 1 is 2, right? But x to the power 0 will give me 1. That is why this x component disappeared. So this is the solution for this particular kind of differentiation. So I'll quickly walk you through some example. For example, using power rule. If, for instance, I have y is equals to 5x raised to the power 4, okay, and I'm asked to do dy dx of this particular one, dy dx of this particular function. So this is a constant term. I'll just bring it out, or I'll say 4 this power times this coefficient. So I will say 5 times 4 times 4, then x, then this 4 reduced by 1 at the same time, 4 minus 1, you understand? So 5 times 4 is 20, x to the power 4 minus 1 is 3. So this is the answer. So that's using power rule. Power rule. Now if I have this other function, y is equals to x cubed plus 4x squared plus 6x plus 5, for instance. To differentiate this, dy dx of this is, I'm going to be differentiating all these terms individually one by one. So this first term, this first one here, x to the power 3, is same thing as 3 times 1. 3 times 1. 1 is what? The coefficient of x. 3 is the power or the exponent. Exponent times coefficient, 3 times 1 is 3, then x, then the same exponent reduced by 1. 3 minus 1 is 2. Plus, again, 4 is the exponent here. 4 times 4, 2 times 4, not 4. 2 times 4 is 8. 2 is the exponent, and 4 is the coefficient. 2 times 4 is 8, then x, at the same time, 2 minus 1 is 1. Okay, so plus, then again, I have the power here, 1. 1 times 6 is 6. But that same 1 minus 1 is 0. So x to the power 0 is 1. So it's times 1. I will not write x again, it will be times 1, right? Then for a constant term, one of the rules I share with you, for the constant term is 0. So I don't have anything for this constant term. So I will write this again as 3x squared plus this 8x, right? Plus then 6. Nothing here. So this is the final differentiation of that particular function. 3x squared plus 8x plus 6. Okay? So move to more examples. So if I have y is equals to 7x squared minus 2x plus 9. So this one, dy dx is equals to 2 times 7 is 14. 2 minus 1 is 1, right? Minus, then this is power of 1. 1 times 2 is 2. 1 minus 1 is 0. That's x to the power 0. Plus this 9 is a constant term, will give me 0. So the dy dx simplified now becomes 14x minus 2, because x to the power 0 is 2, then plus 0. So this is the answer for this particular question. All right, so I have this one that is negative power. If, for instance, you have y is equals to x raised to the power minus 2. Okay, let me take this off so that. So I have y is equals to x raised to the power minus 2. All right. Now, for this one, this minus 2 is the exponent, is the power, so it's negative. So minus 2 will come down to multiply 1. So I have dy dx is equals to minus 2 here, then x. Then this minus 2, the same time, reduced by 1. So minus 2 minus 1 is minus 3, right? So I have answer minus 2x raised to the power minus 3. But you know that you can also spread this as this form, minus 2 all over x to the power 3. Why? Because the law of indices says that if I have the power of the variable as a negative number, that's the whole of that variable and the power will come down and the negative will disappear. So this is just indices, law of indices, right? So this is the answer for this particular question. So we'll go on to product rule. So for product rule, when we multiply two functions together, you can't just differentiate them separately, just like as we are doing for sum or difference. So you what they call product rule. So if, for instance, I have a big function, y, if y has two functions, if y has u function of x and times, not plus, times v function of x, all right. So these are two functions multiplying each other. So we will now use product rule. Product rule states that dy dx is equals to So I will take this one, this particular function, I differentiate this one and multiply by this. Yes? And I will add a2, differentiate this, multiply by this. Okay, I'll do it. I'll write it out. So I will say u dv times my word du times v, right, plus dv times u. So this prime here on this means that I have differentiated u function. I'll differentiate this one, multiply by this, and differentiate this one, multiply by this. Anyhow you want to do it, anyhow is commutative. You can do it this way, this way. You understand? You can start like this and end like this, but you are adding together, right? So what you do here is that you differentiate this one and multiply by this. That will give us first term. Then differentiate this one and multiply by this. So I can come out and say this did this plus this did this. You understand? It's confusing, right? Let me do it again. Just hold up. Okay, so I can say this my hand is this, right? Then did this plus this. When I put this, I'm writing it out, right? Then did this. So this here means the differentiation. I can see that like this. This did this plus this did this. You see? Different way of writing this thing. This one is differential. Differentiate this function. Differentiate this function. You see? Differentiate this one and this one are the same thing. Like I said, it's commutative. I can twist it. This one and this one are the same thing, right? This one and this one are the same thing. Why this and this are the same thing? So I've written it in three different forms. But the product rule states that I will differentiate this one, multiply by this, have it as one term, then plus differentiate this one, multiply by this. So, okay, we're going to apply that. We'll get used to it very soon. Product rule, we'll apply that now. Okay, now, when you have something like this, y is equals to x squared sine x. Now, there are two functions instead of this. So this is a function here, and it's a function here. It's not a uniform function. There's one function. This is a quadratic function, and this is a trigonometric function. So there are two functions here. So to do this, I will say let u is equals to s squared and v is equals to sine x. So once you see this product, you use product through differentiation. dy dx is equals to u dv dx plus v du dx. That is, this did this plus this did this. See? A time will come when you will not even have to write this out. If you are doing objective, for instance, you have multiple choice questions. You now start writing this thing out like this. Just from top of your head, this did this. Okay? So I come here. This is what? U, right? X squared. So this x squared, I'm not touching x squared, but I want to differentiate this. This is cos x, right? Differential of sine x is cos x. Okay? Plus, then I have this sine x, this. This is what? 2x. 2x. All right, so final answer here looks like this. I can say 2x sine x, that's I write this one first out, then plus x squared cos x. So this is the answer. This is the answer. Okay? So I'm going to quickly do another product rule. So if I have y is equals to 3x squared plus 1, bracket open, bracket close, 2x minus 5. These are on our product of this function and this function. I can come here, I will say, let u be the first function, 3x squared plus 1, and v, next function, 2x minus 5. So there are two functions here. So dy dx is equals to this this plus this this. That is this plus this this. This is the product rule function. Okay, so you can write it out like this, or you can write that and say u dv dx plus v du dx. Anyone, just make sure that one of them is standing alone, the other one is being differentiated. Then you flip it, the other one is standing alone, and the first one is not differentiated. Understand? So let me go to this one. So this is what I'm differentiating. So if I follow my convention here, dy dx is equals to, so if I follow this convention here, u is standing alone, 3x squared plus 1 will stand alone, 3x squared plus 1 stand alone, then times, I differentiate v. This one, differentiation, is just 2. Why? Because 5 is already 0, and x raised to the power 1 is x raised to the power 0 when you differentiate it. So this is just 2. Plus v, this is v. V stands alone, 2x minus 5. And u is differentiated to be 2 power of 2 times 6 times 3 will give me 6x raised to the power 1. Understand? So this one 2 is 0. So this is the final, this is the answer. Just for me to just what's it called? To just dress it. This 2 is multiplying everything here. So 2 times 3 outside, 2 here times 3x squared is 6x squared, plus 2 times 1 is 2, then plus 6x times 2x is 12x squared, then this times this is 30x. So I can collect like terms. This and this will give me 18x squared minus 30x plus 2. This is the final answer. Dy dx is equals to this. This is the final answer for this particular one. Okay? So we're going to the last segment for this video. We call it the quotient rule. For the quotient rule is when a function is divided by another function. We have, for instance, y is equals to u over v, where u is function of x and v is function of x. Understand? So therefore, dy dx is equals to v du dx minus u dv dx all over v squared. Okay. All over v squared, right? All right. Now, I like to write this to my students. Now, how can you read this? This is bottom, the top, minus top, the bottom, over bottom square. Again, bottom, the top, minus top, the bottom, over bottom square. How does this apply? So, I have a function like this. Remember, I just write, what's bottom? Bottom is v, right? Bottom, the top, minus top, the bottom, over bottom square. So, you know what bottom is? Bottom is actually the denominator, and the top is the numerator. So just read this out again, like bottom, the top, bottom, the top. Bottom, you write it out without touching it. Then the top, you differentiate the top, right? Then minus top, write it out without differentiating it, then differentiate the bottom over then bottom square. Now let me quickly apply what I'm just saying in this particular question. Take this off quickly. So I have, if I have y is equals to x squared plus 1 all over x, right? So this is a quotient rule where the first one, the top is x squared plus 1, that's the top, and the bottom is x, right? So I'll just come here and say dy dx, even if this one is u and this one is v. I know, this is u, right? Upstairs is u, top is u, down is v, right? But I will come and say bottom the top. Bottom is x. Then d top is differentiate this top, right? So I have 2x. Then minus top is x squared minus plus 1. X squared plus 1. Then top the bottom. The bottom is 1 over bottom square. So I've cut all this long, I can write the formula, of course. Dy dx is equals to v, that's v is down, v d up minus minus u then v squared, right? That's the formula. But bottom the top minus top the bottom over bottom square. Okay, so at this point I'll just simplify the expression. Apply the expression. This times this is same thing as 2x squared, right? Minus, then this times this is x squared minus 1. You understand? This minus has turned this one to be minus at the same time. Okay, over x squared. That's dy dx. All right. So I can now separate each term with the denominator. So I say 2x squared over x squared minus x squared over x squared minus 1 over x squared. So this will cancel this will cancel this. So final answer, simplified form, y prime is 2 minus 1 minus x raised to the power minus 2. That looks like more of the answer. Okay, 2 minus 1 is 1, right? Okay, I'm still trying to simplify further. 2 minus 1 is 1. So y prime means differentiated y. That's the function is differentiated. It's equals to 2 minus 1 is 1. And this is minus 1 over x squared. So this is the answer for this. That's the answer for this. We'll do one more. And wrap up the video. Okay, so we have this on the board now. Y is equals to x squared minus 1 over x squared plus 1, right? So this is a quotient rule where we have let u is equals to the top and v is equals to the bottom. Two expressions, one top, one bottom. So the formula actually dy dx is equals to bottom, this bottom, then the top minus top the bottom over bottom square, right? So I'll just write it there. Bottom is x squared plus 1. The top is 2x. Okay, at this stage you should just know how to differentiate this thing without thinking about it. Yeah. Okay, minus top, this top, then the bottom is 2x over bottom square. Bottom square is 2x squared plus 1 all square, right? Okay. So at this point, we quickly simplify. By simplifying this, so 2x is 2x cubed plus 2x minus 2x cubed again plus 2x, right? Because minus is plus. All right, all over x squared plus 1 all square. So I will simplify this one. This and this will cancel, right? This and this will cancel because they are, so this and this will give me 4x all over x squared plus 1 all square. So this is the final answer for that derivative. Just study everything. A point will come where you combine all the rules, but you are being able to, from this video, to identify which rule to use depending on what you are seeing. So I hope this video has been informative for you, and I'd like to thank you for viewing. Please subscribe to our channel and share to other students of National Open University, and to everybody who likes the STEMs to follow us on this channel.